Welcome, and thank you for coming along. Today we're going to look at early days in African historical cartography, from the Portolan charts to printed maps. In effect, the Portolan charts are very important in the history of Africa, as is illustrated here in 1502, only 10 years after Columbus discovered, in quotes, the New World. Then, printing is crucially important. In fact, it changes the whole nature of depicting Africa. Just 61 years later, after the Portolan chart, which is a manuscript written by hand, to the printed maps, 61 years later, now preserved at Yale, there's an extraordinary change in emphasis, in vision, in the imaging and the imagining of the African continent. So we're going to look at this whole question in terms of imaging, imagining Africa in the Atlantic system. Imagining is quite different 61 years later, and the imaging is different as well. Imagining is different because Africa is conceived an entirely new system, the Atlantic system. This area here, even though the map appears upside down, is what's new about the imaging and imagining of Africa. Major scholarship has recently been published by Alida Metcalf on the charting and mapping of the Atlantic system. Similarly, thorough research is now needed for the continent of Africa as a whole, not just the Atlantic system, that is to say, the oceanographic system which emerges in European consciousness, but the continent of Africa, which also emerges in European consciousness. This task is in its early days. So we're looking at early days in African cartography in two senses here. Early days in terms of the maps themselves, some of the earliest maps, but also early days in terms of the conception of what needs to be done in the scholarship we've just begun. African and world historic cartography has been considered for a while because Africa figures prominently on some of the earliest of the world maps. In fact, the Valsamiller map, discussed here by John Hessler of the Library of Congress, is often referred to as the birth certificate of the American continent because it mentions America for the first time. But it's clear that Africa is central in this map, even though it's often not discussed. Dr. Hessler drew our attention not only to the images on the map itself, but particularly to the problem of what he called transmission. He's pointing here to the cartouche in the lower right of the map, which is a printed text in Latin that indicates that the producer, Martin Balsamiller, in fact thought this would change people's view of the world. It was an ambitious presentation of the world in which he presented the American continent and called it America for the first time after the Italian geographer Amerigo Vespucci, not after Columbus, but after the cartographer and explorer Amerigo Vespucci, who realized for the first time that the New World was truly new, not a simple projection of what Columbus thought, a westward access to Asia. In fact, Dr. Hessler has posed a series of underlying questions about the cosmology and epistemology of map makers and the circuits of transmission they reveal as a crucial topic that deserves our extended research. Let's listen to what he had to say.
Historians of science generally divide unsolved problems into really two different camps. One, factual. Those are things like, is the JCB map printed before 1513? Do the 1507 globe gores come before the 1507 map? All of these sort of factual controversies that surround Waldseemüller scholarship. And the other part of it is historians of science tend to talk about conceptual issues. And those of you who know any of my work know that I'm really not so interested in the factual stuff. I'm much more interested in the conceptual grounding of the things. What I want to know is, how did Waldseemüller think? What was it like to be a humanist cartographer sitting in Santiago trying to come to terms with all of this new information that was coming at them? Now, so I'm going to deal with just a few conceptual issues today. One, and from my perspective, the most important issue conceptually and historically in any scholarship on early maps is the problem of transmission. It's an issue that is rarely dealt with in scholarship in any detailed way. Most of the cartographic scholarship deals with what I will call coastline matching. This map must have come from this map, must have come from this map. Also a lot of linguistic work. And that's interesting, but it doesn't really give us any sense of the networks of transmission. How is this information flowing? What networks are being established that allow this information to flow?
He's underscored that all historical maps present complex questions that deserve both extended factual research and in-depth humanist scholarship in the history, culture, and worldview of the map makers and publishers. With these valuable guidelines in mind, how might we most fruitfully undertake African historical cartography? Well, Dr. Hessler gives us a very important way to approach this by looking at another Waldseemüller map called the Carta Marina, published in 1516, just 9 years after the 1507 map. Dr. Hessler helped to convene and conduct a very important series of deliberations entitled Facts or Fictions, Debating the Mysteries of Early Modern Science and Cartography, looking particularly at the Carta Marina at 500 years on in 2016, 500 years from its publication in 1516. Facts and Fictions, the Mysteries of Renaissance Cartography. He gave a generous introduction to Ralph E. Ehrenberg, highlighting the lifelong work of the head, the chief of the Geography and Map Division in the Library of Congress, who was on the verge of retirement at the point of this conference. It's a very moving introduction. Listen to it if you have access to the material. He also gave an indication that he had worked on the Waldseemüller earlier maps, the 1507 map. It was published 9 years before the 1516 world map, and that he had worked with Chet van Duzer very closely, published a book, actually, together on seeing the world anew, the importance of these two maps in changing European consciousness of the world as a whole. Further, he provided an introduction to a scholar that we haven't fully understood or appreciated yet in the Western world, because his scholarship is based in Europe and European tradition of cartography that we have yet to learn about. It's Joachim Gaspar. Joachim Gaspar is at the University of Lisbon, and he gave an important address at this conference entitled Maps and Nautical Charts in Early Medieval and Early Modern Ages. Two of a kind or different cartographic paradigms. It was quite a revealing study. He began by underscoring the difference between charts and maps. Simple enough, and he illustrated it with an example from Washington, D.C., where the conference was taking place. In the Chesapeake Bay, obviously there are nautical charts, because people need to navigate in and out in small craft and larger ships. There's also a topographic map. Now, a chart is different from a map because a chart deals with oceans and their depths and the angles at which currents flow and how to orient yourself towards a compass. Whereas the topographic map deals with land masses, and relief maps like this one indicates heights and nomenclature of various spots on the map, which are absent over in the nautical chart because they're relatively indifferent towards what's on land. They're focused on the ocean. Well, this was a simple illustration of what he went on to explain as a huge difference between charts on the one hand and maps on the other, made contemporaneously throughout the 16th century about Africa. Let's listen to the full introduction that Dr. Hessler gives to Joachim Gaspar, because in fact it's a very important indication of how crucial Dr. Gaspar's insights are.
This afternoon we've got a really great program for you, mostly focused on the Carta Marina and nautical charts. Obviously the Carta Marina is itself a large printed nautical chart, very different from the 1507 map, and to a certain extent it is somewhat the understudied sister of the 1507 map, which has its own little nickname, the Birth Certificate of America, and various other sundry theories associated with it. The Carta Marina seems to have been largely ignored, except for a few people who've actually done very intensive work on it. Our first speaker today, this afternoon, Joachim Gaspar, is one of those scholars who not only does intensive and deep scholarship, but one of those scholars who transform a discipline, transform the study of a particular type of object. Joachim, whose dissertation committee I was on when he received his doctorate, I'm not being, one-sided here, but it was a very good defense, basically has begun to apply very analytical tools to some of the interesting technical questions associated with not only things like Portolan charts, but also mysteries like the Mercator projection. How was it mathematically constructed? He's done a lot of work and published in many essays and in Imago Mundi and several other journals. If you've never read his dissertation on Portolan charts, I would suggest it is required reading. He has just recently received one of the first millionary research grant from the European Research Council in the history of cartography, since the European Research Council was founded, to study the technical developments of the Portolan chart. And so without further ado, Joachim.
Thank you very much. Before I start, let me just say how honored and I feel to be here, and I have to thank John for inviting me. Well, the title is not exactly the same as in the program. Anyway, I promise you that it will be equally exciting. Can you hear me? Not too loud? No, okay. I would like to start my talk by showing side by side two different kinds of modern maps depicting the same region of the world, the well-known Chesapeake Bay. A nautical chart on the left and a topographical map on the right. The differences are obvious. In the topographical map, the information is concentrated inland, leaving the wet areas almost totally empty. In the nautical chart, most of the information is located at sea and in the coastal areas closest to the sea, leaving the dry land virtually blank. The reasons for these differences are, of course, related to the different purposes of maps and charts. While topographical maps are intended to depict all kinds of general information relative to the surface of the Earth, nautical charts are constructed with the specific goal of supporting marine navigation. But of course, these are old news for those of you who are acquainted with maps and charts. However, when we look into the historical evolution of nautical cartography, we realize that the differences between these two types of representations are much more profound than expected. That is the subject of my presentation today. I will show, using examples taken from various periods, that historically maps and nautical charts not only had different geneses, but also were constructed with different purposes and according to different principles. The fundamental difference between maps and charts was, in a limited way, already expressed by the late American cartographer Hessler, who stated in his well-known book Elements of Cartography, and I quote, "Maps are to be looked at while charts are to be worked on." Although Robinson's definition is wonderfully expressive and synthetic, it doesn't tell the whole story or even the most exciting parts. In my talk, I will show how closely connected are the geometry and the construction processes of nautical charts throughout history to the navigational methods they were intended to support, and how the confusion between what should be considered as an accurate map and an accurate chart often led to misunderstanding and conflict between pilots, cartographers, and cosmographers. Only in the present day can we see more clearly through the mist caused by some subtle technical questions that the protagonists of the past were unable to interpret and fully understand the reason for those misunderstandings, which is the intrinsically different nature of maps and charts. This is a nautical chart drawn by a Genovese cartographer named Angelino Dolcetti in 1339, depicting the Mediterranean, the Black Sea, and the Atlantic coast of Europe and Africa. It is just one example of the many similar charts that were produced in the workshops of Genoa, Venice, or Majorca from some uncertain date of the early 13th century on, the so-called Portolan charts of the Mediterranean. When we compare this representation with the typical world maps of the Middle Ages, usually drawn by erudite clerics, the differences in accuracy and detail are remarkable. So remarkable that a number of historians, probably influenced by the old myths of the Dark Ages, have fallen into the trap of considering that the accuracy of those charts was not within the reach of the medieval cartographers. The way out of this death alley was to postulate that the medieval Portolan charts were in fact copies of lost prototypes made by some ancient civilization using sophisticated geodetic methods. However, no piece of historical evidence has ever been produced in support of such extraordinary claim, and the medieval origin of Portolan charts is now consensually accepted by most historians of cartography. Furthermore, the popular idea that Portolan charts are extremely accurate by present-day standards is not correct. Although the general outline of the Mediterranean with its bays, capes and islands is easily recognizable in them, a closer look into their overall geometry and detail reveals important inaccuracies. The most obvious, although by no means the only one, is the orientation of the Mediterranean itself. When we compare the chart of Angelino Dolcetto and the modern representation of the Mediterranean, such as this one taken from Google Earth, we realize that the north-south direction in the old chart, as defined by its vertical top-down lines, is tilted counterclockwise by an angle close to 10 degrees. Why is that? How could the cartographers of the 14th century make such a mistake when they were perfectly aware that the direction of the geographical north could be easily determined by observing the pole star? In the beginning of the 15th century, some 200 years after the first Portolan charts were created, Ptolemy's geography was translated into Latin and maps of the known world based on its extensive list of coordinates were produced, like this one. Comparing the representation of the Mediterranean in the medieval editions of Ptolemy's geography with the corresponding representations in the contemporary Portolan charts, one realized that while Ptolemy's maps are correctly oriented to the geographical north, like this one, Portolan charts continue to be tilted counterclockwise, as in the older chart of Angelino Dolcetto. Once again, how could the cartographers persist on the same mistake, this time defying the recognized authority of Ptolemy? The enigma is even more perplexing when you realize that the overall accuracy and detail of the Portolan charts, except for this particular feature, was much better than the one of Ptolemy's maps. The explanation for this apparent inconsistency is that we are comparing two distinct cartographical models. While both the modern maps and Ptolemy's representation of the world on the left are based on the geographical coordinates of the places, latitudes and longitudes, Portolan charts on the right were based on navigational information collected at sea, courses between ports measured with the magnetic compass and distances estimated by the pilots. Let me underline the following point, which is critical for understanding the argument of my whole talk. The geometry of a map constructed on the basis of latitudes and longitudes is usually very different from the one of a chart based on magnetic courses and distances between places. Let me explain. As we all know, the direction indicated by the North Pole of a magnetic compass, the red one in the figure, does not usually coincide with the direction of the true north, the geographical north. To the angle between the two directions, the angle delta in the figure, we call magnetic declination. At the time the earliest Portolan charts were constructed, during the 13th century, the average value of magnetic declination in the Mediterranean was about 8 to 10 degrees, which is also the average tilt of both charts. This is not by chance, of course, because charts were oriented with the compass top north on top. Not only charts were constructed using the courses between ports measured with the magnetic compass at sea, but also they were used to support navigation exactly the same way. Putting things in simple terms, the course actually steered by a ship navigating from one port to another as indicated by the magnetic compass, should match the corresponding chords measured on the chart. That would not be the case if a common map were used. Thus, both Ptolemy's representation of the world and the modern map on the left are not directly comparable with the Portolan chart on the right because they belong to distinct cartographic paradigms. While the first two are intended to represent the land masses of the world as faithfully as possible, using whatever map projection is considered the more appropriate, Portolan charts were specifically conceived to support the practice of navigation. Can we say that Portolan charts were inaccurate because the direction between places measured on them did not match the true geographical directions? It is the very concept of accuracy which is at stake here. In the present day, a map is considered accurate when the coordinates of the places, the latitudes as well as the longitudes, are accurate. Can we apply this same concept to a medieval nautical chart which was not made on the basis of the latitudes and longitudes of the places? If not, what criteria should we apply to assess the accuracy of those charts? Taking into account the fact that Portolan charts were constructed with the purpose of supporting navigation, the natural way would be to evaluate to what extent they were fit to that same purpose. Let me give another example taken from a different period. This is, of course, the Cantino planisphere, drawn by an anonymous Portuguese cartographer in 1502 and immediately taken to Italy by an emissary of the Duke of Ferrara, Alberto Cantino. The Cantino planisphere is one of the most precious monuments of our cartographic heritage, depicting the world as it became known to the European nations after the great discoveries of the 15th century to Africa, Newfoundland, Central America, Brazil, and India. Notice how these regions are already represented in their approximate geographical locations and how much detail some of them show. Also, and following the introduction of astronomical methods of navigation during the second half of the 15th century, this is the earliest ancient chart where places were represented according to their latitudes. With the Cantino planisphere, a new cartographical standard was established, promptly adopted by many other world maps of the beginning of the 16th century, like the Caverio planisphere and the two printed world maps of Martin Waldseemüller engraved in 1507 and 1516, now kept in the Library of Congress, of course. Once more, the question I would like to propose regarding these early modern nautical planispheres is the following. How accurate are they? Very often, historians have tried to give an answer to this question by comparing the coastlines depicted on these maps with those of modern representations. If we apply the procedure to the outline of Africa in the Cantino planisphere on the right, by using a satellite image of the Earth as a model on the left, the result is surprising. Notice how, in the old chart, the contour of the continent appears grossly displaced and stretched in the east-west direction, making the Isthmus of Suez look enormous. How can we explain this mistake, which was replicated in all cartography of the 16th century and beyond, including Waldseemüller's Carta Marina? Various explanations were given by the historians. Some have considered that the apparent distortion of Africa, the normal result of the poor surveying techniques of the time, when longitudes could not be determined accurately. Others postulated that the exaggerated longitudinal extent of the continent was copied from Ptolemy's geography. We will see that both explanations are wrong. in order to put ourselves firmly within the navigational and cartographical reality of the time and avoid anachronism, let us imagine the following experiment. Suppose that we take part in a surveying maritime expedition in the beginning of the 16th century with the purpose of representing the coasts of Africa on a chart. Departing from Lisbon, the idea is to sail around the African continent up to Cape Guardafui, keeping the ship as close to the coast as possible. All we have available as navigational instruments is a magnetic compass to steer the ship and a nautical astrolabe to observe the sun and determine latitude on board. We are further requested to keep a navigational record containing the courses steered and the latitudes determined along the route, as in this table. After the trip is completed, the next step will consist in representing graphically the ship's tracks on a modern map using the courses and the latitudes noted in the ship's log. The first track in the log is the one connecting Lisbon to the island of Madeira. The course is approximately southwest and the latitude of Madeira is 32 degrees north. The second is between Madeira and the island of Tenerife in the Canary Islands. The third between Tenerife and Cape Verde Islands, and so on around the southern tip of Africa and up to Cape Guardafui. The result is totally unexpected, as it seems to contradict our direct experience. The coastline was in sight most of the time, and Cape Guardafui was indeed reached at the end of the voyage. Something went very wrong, but what? Well, knowing that our experiment has taken place in the 16th century and that we have used an ordinary magnetic compass to measure the courses, it is expected that those directions were affected by magnetic declination. If that were not the case, the track recorded in our log would look like this, of course. However, in the beginning of the 16th century, magnetic declination had a peculiar spatial distribution in the area. It was east in the Atlantic Ocean and west in the Indian Ocean. This made all compass courses in the Atlantic to have negative errors, causing the corresponding tracks to appear rotated counterclockwise, and all compass courses in the Indian Ocean to have positive errors, making the corresponding tracks to appear rotated clockwise. This fully explains why the route, that we have transferred from the ship's log to the modern map looks distorted. Thus, can we conclude that our compass was faulty? Not really, because it behaved exactly how it was supposed to behave. Although the pilots of the 16th century were perfectly aware of the phenomenon of magnetic declination, no corrections were made to the courses measured by the compass. More importantly, and this is a critical point to understand the nautical cartography of the time, no corrections were made to the directions used to make the very charts. Thus, it won't come as a surprise that our track around the African continent, which was determined with a magnetic compass, almost exactly matches the coastline in the Cantino planisphere. Now, coming back to the initial question about the accuracy of this chart, it seems now clear that once again the usual criterion of cartographic accuracy based on the latitudes and longitudes of the places should not be applied here. That was the mistake not only of the present-day historians, but also of the cosmographers of the 16th century, as we'll see next. Around 1560, the Portuguese cartographer Lopo Homem, in a note addressed to the Crown, harshly complained about the new official cartographic pattern that was enforced by the cosmographer Major, the mathematician Pedro Nunes. According to him, such pattern was prepared using the eclipses of the sun and moon in order to show that from Lisbon to India and to the Moluccas there was less distances than shown on the traditional charts. However, and these are the words of Lopuome, the charts made according to the new pattern, and I quote, were so widely distanced from all truths and navigational science that many ships had been lost and the pilots were forced to buy their charts in Castile. At the time this letter was written, everybody knew that the longitudinal distance between Lisbon and India, as shown in the contemporary charts, was exaggerated. In a treatise written some 30 years before, the same Pedro Nunes had already complained about the fact, which he attributed to the incompetence of the pilots. Although Pedro Nunes was absolutely right about the exaggerated longitudinal distance between Lisbon and India, he was absolutely wrong that the pilots were to blame. In 1547, he was appointed as cosmographer major, becoming responsible for the royal cartographic pattern. Then he finally had the opportunity to correct what he considered to be a major mistake, and so he did, by ordering the longitude of Dio in India to be determined by astronomical methods. The result was a new representation in which the longitudinal distance between Lisbon and India was substantially shortened, as in this chart of Lopuome himself. Why did the cartographer consider this model widely distant from all truth and navigational science? What kind of error would make a chart so unfit for navigation? Clearly, he was not referring to the distances, usually not to trust on the contemporary charts, but to the orientation of the coastlines, which no longer reflected the compass courses between places. Who was right and wrong in this dispute? Pedro Nunes, who used scientific methods to determine the longitude of India and enforced his interpretation onto the official cartography, or Lopuome, who complained directly to the crown and supported his position with practical arguments concerning the safety of navigation? The answer to this question depends on the use of charts. If they were indeed intended to support navigation, then Pedro Nunes was wrong and Lopuome was right. In no way could the two requirements be conciliated at the time. In 1569, Gerard Mercator presented his map of the world with the revealing title, and I translate from the Latin, New and Improved Description of the Earth, properly adjusted for the use of navigation. In this map, meridians and parallels form a regular mesh of rectangles where the spacing between parallels increases with latitude in such a way that rhumb lines, or lines of constant course, are represented by straight segments, making the correct angle with all the meridians. In theory, this solution would facilitate enormously the planning and execution of navigation. But was Mercator's world map truly adapted to navigation at the time it was proposed? As a matter of fact, it was not. More than 200 years had still to pass before the novel projection could be fully adopted by the pilots, not because the pilots were conservative or ignorant, but owing to its incompatibility with the navigational methods of the time, still based on latitudes and magnetic courses. Only after the longitude problem was solved and the distribution of magnetic declination was known could the old cartographic model originated in the Cantino planisphere be abandoned for good and replaced by the Mercator projection. But the story is not over. When we look closely into the geographical content of Mercator's world map, we realized that places are not really represented according to their latitudes and longitudes as they should. If we compare its depiction of Africa on the right with the one on a modern Mercator's map on the left, we realize with amazement that the same old east-west displacement is still present. How should we interpret this unexpected mistake? The fact is that Mercator could do no better than transferring directly the coastlines of the maps and charts of this time to the novel projection with no concern for their distortions, assuming wrongly that both the latitudes and the longitudes of the places were approximately correct. Could he have made a better job? Not really. In order to construct an accurate Mercator representation, a new survey was required, this time based on the latitudes, the longitudes, and the true direction between places. As we know, such endeavor could only be started after the longitude problem was solved near the end of the 18th century. And I'm coming to the end of my presentation. 3 different navigational cartographic models were developed throughout history. The Portolan chart based on magnetic courses and estimated distances, the latitude chart based on magnetic courses and latitudes, and the Mercator chart based on geographical coordinates and through rhumb line directions. Not only these 3 models were designed to support specific and distinct navigational methods, but also they were mutually incompatible. We know that the content of nautical charts was routinely used to construct lavish depictions of the world to be offered to emperors and popes and to be employed by them as symbols of glory and national power. At the time, however, none of those people were aware of the fact that such representations were not real maps and that the continents, the islands, and the coastlines were distorted in weird and unsuspected ways. These distortions were noticed by the instructed cosmographers, who insisted to have them corrected, being systematically opposed by cartographers and pilots who invoked the safety of navigation. Only today can we fully understand the subtle technical reasons behind these disputes and conclude, first, that historically nautical charts can only be understood in the context of the navigational methods they were intended to support. And second, that a nautical chart should not be considered as a true geographical map, but as a diagram to support navigation. Thank you.